Alright, so the first thing that we're going to look at in set theory is the idea of subsets. Alright, now the word subset should make sense. It's a set inside of another set. Alright, and what I mean by that is we say A is a subset of B if all of the elements of A are in B. So let's take an example. If A is the set 1, 2, 3, and B is the set 1, 2, 3, 4, 5, it's clear to see that all of the elements of A are inside of B. So A is a subset of B. Okay? And the way we write that, and it doesn't show up on this, but is this way. It's A, and it's almost like a less than symbol, but we make it round. So it's kind of like a less than or equal to symbol, except we round it out when we're talking about sets. Okay? So that's what it looks like. All right? A is a subset of B. Alright, so I want to look at a few sets here and kind of use this to illustrate the properties of subsets and what can be a subset of what. So first off, we're going to let A be the set 1, 2, set containing elements 1, 2. B is going to be the set containing the elements 2, 4, 6, 8. C will be the set containing elements 1, 2, 3, 4, 5, 6, 7, 8. And D will be the set 1, 2, containing 1, 2. And then we'll have an empty set that we'll deal with as well. Alright? So it should be clear that if I look at A and C, I want to draw a line here. A is a subset of C. All of the elements of A are in C. And we see that B is a subset of C as well. Okay, all of the elements of B, 2, 4, 6, 8, are inside of C. If you notice, the subset property is not necessarily reversible because C is obviously not a subset of A. And C is obviously not a subset of B either. Okay, I'm just drawing a line through this showing that that it's not a subset. It's kind of like the not equal to. So let's take some more interesting things. First off, if I look at A and D, it turns out that A is a subset of D. Remember, our definition is, does every single element in this set exist in this one? And since they're equal, yes, they are subsets. A is a subset of D. Okay. And by the way, just since they're equal, D is also a subset of A. By the way, if we have equality, that's the only time we get this relationship where both things are subsets of one another. Okay, no other time can we get that relationship, those two relationships together, unless they're exactly equal. Okay. By the way, not everything has to be a subset. Notice that A and B, A is not a subset of B because the element 1 in A doesn't exist in B. So A is not a subset of B. But also B is not a subset of A because the element 4 in B doesn't have anything in A. There's no 4 in A. Okay. Now, what about the empty set? It turns out the empty set the set containing nothing. Well, think about the definition. We'll compare this to A. All right. It says all of the elements in a set, so we're thinking about all of the elements in the empty set, are in here. Well, there's no elements in the empty set. So that is what's called trivially true. So yes, in fact, the empty set is a subset of A. In fact, the empty set is a subset of everything. It's a subset of B. It's a subset of C. By the way, there is this property that if all of the elements in one set are in another, oops, I thought I had that. If all the elements in this set are in this set, and then if all the elements of A are in C, then the empty set has to be a subset of C as well. Okay, that's a property. You can prove that two ways. One, just by looking at the empty set. The other is if we had another set. Let's call it E. We'll just say it's the element number 1. Well, since E is a subset of A, and A is a subset of C, that implies E has to be a subset of C, right? If all the elements are in A, and all the elements of A are in C, we get all the elements of E are in C. All right? So, on the homework on the quiz and in the practice problems, you'll be asked to figure out which are subsets of which are subsets of which sets are subsets of other sets. All right, one thing you probably noticed was that obviously A is a subset of itself. So that happens regardless of what a set is. So if I give you any set, let's call it S, it is a subset of itself. Okay, we can't have a subset of the original set. So one thing we'll often talk about is something called a proper subset. A proper subset, so A is a proper subset of B. A proper subset of B if A is a subset but not equal. All right? So if we have a subset and it's not equal, then we call it a proper subset. Okay? So the empty set is a proper subset of anything unless it's trying to do it of itself. So anyways, I just wanted to get that out there. If you ever see the word proper subset, that just means it's a subset, but it's not equal to. We call, oftentimes we call the set itself and the we call the set itself and the empty set trivial cases for subsets. So we say proper subset if it is a subset, but it's not equal to. Now, just so you understand that we're not always talking about numbers, I wanted to reinforce the idea. So let's assume that our set of the U.S. states is our universe, or maybe it's just A or whatever it is. New Jersey, Illinois, and Pennsylvania, is that a subset of the United States? And the answer is clearly yes. All right, that is a subset of the U.S. states. Arizona, Ontario, Michigan. Well, Arizona and Michigan are U.S. states, but Ontario is not. So this is not a subset of the United States. All right, of the U.S. states is what I mean. The 50 states in the United States. All right. Now the ideas of sets in general can be illustrated through with the use of Venn diagrams. And what we're going to do is we're going to focus a lot on Venn diagrams because in later chapters it is helpful to understand, how things work out and how things are being put together. And if we have a visual of the idea, then it's going to help us tremendously. So let me talk about Venn diagrams. Basically, a Venn diagram is just a picture where typically we draw a big rectangle, and the rectangle is going to represent our universe. I'll call that U. Okay? So we're thinking of everything in our universe as being inside this rectangle. And then inside of that, we're going to have certain sets. So we may have, one set here, which is an A. We may have a set which is a B. We may have some other sets. Maybe some of them don't overlap. That's probably a bad color to choose. Maybe some of them don't overlap. Let's call that one B. Maybe some of them do overlap. Let's call, a set like this C. Okay? Maybe some of them are, bigger than others. Maybe some of them are smaller than others. So we may have a set D, which is really big. Okay. Now, most of the time this is drawn with circles, but, I've drawn D, so that's kind of oval shaped, and you'll see a lot of that kind of thing happening in Venn diagrams when you get more than one set in the drawing and things like that. So here's what I want you to do. I want you to start out by drawing a Venn diagram and just drawing the idea of A as a subset of B. All right, push pause, try to draw that, and see what you come up with. All right, you should have drawn something like, whoops, let me undo that. You should have drawn something like this. First off, anytime you have a Venn diagram, always start with a big rectangle representing the universe. Now, if A is a subset of B, what we're saying is that all of the elements in here, and by the way, when I say we're representing sets with circles, I'm pretending that all of the elements are inside that circle. So all of the elements of A are somewhere in here. And when I draw a B, well, the B is going to be, it has to be bigger than the A. It has to, because it's A is a subset of B. All of these elements have to be also inside B. Now, B could contain other things. So, for instance, let me just give you a couple examples. If A is the set 1, 2, 3, and B is the set 1, 2, 3, 4, 5, we know that A is a subset of B. So what we're saying is the letters, or excuse me, not letters, the numbers 1, 2, and 3 are somewhere inside this circle. Notice that that also puts them inside of B. But also the numbers 4 and 5 are going to be inside of B, but outside of A. All right? And so that's what the Venn diagrams are doing. And you should be able to draw A as a subset of B. Now, when I say draw it, you're not going to have to draw, a specific example. So you're never going to have to put the numbers in there. But you do have to have something like this drawing. Okay? It doesn't have to have different colors, obviously. But there it is.